Hello, welcome back. So today I am streaming from home. So we are doing things a little bit differently. Unfortunately, one of my kids is sick, so I am staying home and working from home. So this is also why I was struggling a little bit. Oh, and you can see that I only have my laptop at home, so we have to use the same. I only have one screen, as opposed to at work, where I can use a different screen for the streaming and for actually working. Here I only have one screen, so I'm actually using my tablet on the side as actually I'm seeing this as a regular viewer, which is now I can see the lag in real time. So let's start. Actually, since I'm at home, I do not have I have all of the I have all of the data here. I have everything here because so I'm syncing between computers. I use sync thing, so I actually do have the data, but I don't have the Conda environment. So if things work, however, that should not be a problem. That should be an absolutely trivial thing to do. Unfortunately, things might not be as trivial as that, but let's just try it out. Yeah. So I actually forget. I think on this, this should. Oh yeah, I was saying this looked like the old Conda that used to take too long to do things, but no, it's the new Conda, which is fast and good and works. So it's going to be downloading all of these things. So on the one hand, obviously this is unplanned. I did not plan for my children to be sick and for me to have to work on a different computer, especially a smaller one. But on the other hand, it's a pretty good test that if this does not work, or if we run into problems because we are missing some packages, then this will immediately tell us, and then we should be able to fix. Okay, right. So let's see where. So I also want to apologize. I did not record a recap video last week. I've been a bit lazy with those things, and famous last words. But I actually think the following weeks are going to be much calmer in terms of work commitments, and so I will have time to catch up. I've been slowly catching up on all of the on a lot of the my to-do list. But there have been good reasons for this, or happy reasons for this. We've gotten a couple of manuscripts out in the last couple of weeks. So we have this really nice manuscript from Maria Dmitrieva, who did this project on horizontal gene transfer, and I should probably ask her if she wants to do a video on that, or just a short thing here on the channel. That was really nice. It's very comprehensive, and we're using tree reconciliation to find horizontal gene transfer events, including ones that might have happened a long time ago, as opposed to the simpler methods, the simplest method is if you find two chunks of DNA that are very, very similar, say 99% or identical, but they're found in genomes from completely different species, not even the same genus, for example. Then there's two options. One is that's contamination, and the option two is that's horizontal gene transfer. And actually, And actually, many years ago, we realized that contamination was very common, and this is actually what ended up leading to JUNC, this chimera finding tool that Askar Beck and Sebastian and Anthony really worked on. And I'm getting a little bit sidetracked there. I'm sort of rambling a little bit whilst Conda is working. I think I might have the old version of Conda here. Anyway, so we realized that a lot of genomes in the databases, both MAGs, metagenome assembled genomes, but also isolate genomes, which supposedly should not have this problem as much, they still have a lot of contamination. And okay, I'm gonna kill this. I'm gonna just check. I think I'm just gonna rerun it, calling it with Mamba, because so it used to be the case that you had Conda and then Mamba, and Mamba was a newer version, faster, and if you wanted to get the new version, you'd run Mamba instead of Conda. But in the meanwhile, I think the newer version of Conda basically is Mamba, or at least I think they use the same underlying environmental solving library, and so the advantages of Mamba are now integrated into Conda itself. Anyway, so let me just finish this sideline on So if you find two chunks of DNA that are very similar across different genomes, the genomes not from the same species, then that's horizontal gene transfer or an artifact. So if you've eliminated the possibility of an artifact, then that's horizontal gene transfer. However, that will only catch the very recent examples of horizontal gene transfer, because with time, if that new chunk of DNA gets integrated into that genome, then with time that it will accumulate mutations, and there's a nice term for this which I forget. It will start to look more like the host genome. Genomes generally have some sort of they, for example, they typically have a characteristic GC content, right? So the fraction of G and C's compared to A and T's, and when you have some bits of DNA coming from the outside, that might not look like the native DNA, but with time it will accumulate mutations and it will start to look more like the native DNA. And I forget the technical term for that process, to be honest. But by doing tree reconciliation, where we have trees for individual genes, and then we can compare them with the tree from the species, and for the most part they should be identical, right? And most of the because for the most part genes get transferred, mother to child, mother cell to child cell, but we can find the areas where the trees look different, and then there's tools to do this reconciliation and finding these examples or these instances where, okay, what's probably happened is that this gene transferred at some point in its history, and we can get a pretty decent estimate of when it was, even if it was further back in time. Okay, so you should definitely check that out. But in the meanwhile, this has finished. Let's see what we have. We had some stream notes. Okay, and actually we had started doing some of this as well, right? Let me just check where I am. Ahead of main. Okay, did I not push the? Oh yes, because we're in the log. Yeah, we are. So this is where we were. I'm just gonna run this. Oh, okay. Okay, this is because, okay. Yeah, because this is actually because when I'm running NeoVim, when I'm running NeoVim, I actually use a different. Okay, it's actually okay. Okay. What am I looking at? Startup. Okay, now this will go very fast because we just installed it in the other. Yeah, so the problem is when I use NeoVim, I'm using a different version of Python than the one. So here they're out of sync in this computer. And so I installed all the packages, but I didn't use the right Conda environment. And let's see. All right, so now it will install Pronto and Polars, but this will be, it's cached, so it was almost instantaneous. And let's try it again. Oh. Cannot install name unique ever seen from Pronto utils. Okay. Okay, let's see. Sorry, I didn't want to show you my email. Yeah, this is the problem. Here I have fewer. Okay. I'm just not sure. I mean, okay, yeah, okay, I'm gonna do this. Yeah, I think I've in the past I've messed up my installation of Pronto, and by having multiple versions of Pronto on the same at the same time. How do I install Pronto? So this is not ideal, but basically I'm just installing. I'm just going to install Pronto directly from. So I happen to have Pronto here. This is a Git checkout, and I just reinstalled it, and now. So I know I had previously messed this up because I had been playing. So okay, I'm gonna back up a bit. So I do have a version of Pronto here on my laptop, so this was cloning from, and then I think I had installed a couple of different versions, and then apparently then I installed it. I installed now again over that with Conda, and when you do that, sometimes the result is that the different versions don't play well together, and so when you get weird import errors, that's what's happening. So, in the other computer, we're being a little bit more careful, a little, and we're using only one Conda install where everything's being installed from Conda. But here in this environment, everything's just a little bit on top of each other. Which for today, since it's an exceptional situation, it's perfectly okay. See, this worked well. Okay, this is... Okay, also some issue with argnorm. And again, simply reinstall it. Okay, argnorm. Yes, again, we have been we have been obviously working with this. Why doesn't this work? Again, again, just using the nuclear option of just remove everything, install it over it. Okay, now it works. Okay, so this works. Oh, sorry, I bumped the camera. This is the... No, I need to look. Oh, okay. Works well. Okay, so yeah, I'm a little bit. Let me just. Yeah, this is. Okay. It's a little bit dark in here. There's really not much I can do for today. Okay, let's back to... Well, okay, all right, let's everything. Okay, so all right, so it took us about 20 minutes, but we got back where we were last time. And yeah, so in this case, so the instructions that were on the repository on how to install everything worked quite okay. I accept that because I play around in this laptop. I have been playing around with both argnorm and Pronto. This implies that I have multiple versions installed instead of doing it always through Conda in a more disciplined way. So here we use the simple option of deleting everything and reinstalling, which often works quite well, to be honest. So we had seen, so this is what we had seen before. So we have, and sorry about the noise of the construction, there's really not much I can do about that. It's also quite annoying. This is what, so frankly now I would probably just look at this for a bit. There's some sort of, I don't want to get I don't want to get too woo about this, but there's something about just looking at it and, you know, seeing if something emerges where yeah. Okay, that's just so Van T, so you know Van T, vancomycin resistance, tetracycline. So here, you know, I've, you know, some of these, you know, Van and Tet, I mean, these are a little bit self-descriptive that about which antibiotics they confer resistance to, or which antibiotic classes they confer resistance to. But yeah, okay, the other one, okay, this one confers resistance to colistin. Colistin is being an antimicrobial peptide, by the way. It's not a great antibiotic because it you know, as I think I've heard someone say, you know, you take colistin when it's basically your life or your liver, or because it's really can be very toxic, but it's widely used as a last resort. So it is widely used, but as a last resort when, but it, you know, it does intersect a little bit with some of our other interests in that it is an antimicrobial peptide. Efflux, that, so here, clips here. Okay, but these ones I don't, for example, these ones I don't know, I mean, what they are. I mean, like, this is efflux pump conferring antibiotic resistance to what? But I think I think we can find this. We can find this with the Pronto. Cephalosporin. Okay. So this is the great thing about Arrow and about ontologies in general, is that we can really get a lot. We can get a lot more than just the name of things. So does this work? Oops, sorry. Nope. Nope. No, this doesn't work at all. No. Okay, this works. Okay, so this works. This is true. And there's a different one, antibiotic. So let me just, okay. So I just quickly checked that if I try to get a relationship that doesn't exist, that there's an error, and so confers resistance to S does not exist, but confers resistance to an antibiotic exists. And we were actually looking at this the other day, or actually yesterday, to be honest. And what we saw was, so in what seems to be, which makes perfect sense given the name, so an antibiotic is a particular molecule, and the drug class is a group of molecules, potentially. But I mean, potentially, there was one example which I think was interesting because it was a group of one, but it's still conceptually okay, let's try this again. Yep. So it seems, yep. Okay. All right, great. All right, let's do this again. Just delete everything there and look at this again. Okay. Okay, so polymyxin B. Polymyxin B, I think, is just another name for colistin. But, lincomycin, pennams. Okay, so these are just cephalosporin, anthromycin. So it's always a question, how do you summarize these things? Nice, polymyxin B again. So it's like streptomycin, very popular, and then lincomycin, and okay, virginiamycin M1. I have not heard of that one, but it seems to be quite a popular antibiotic, at least in terms of having resistance being conferred to it. Right. Interesting. Okay, this is a little bit. I'm gonna pick this one here. We're still just exploring these things. Okay, let me. Yeah, so I was starting to say before. So we've put a bit of thought internally at, you know, how do you group these things, because there's, and as always there's a bit of trade-off. You know, if you are too broad, then, you know, for example, you know, here you can see a little bit of the hierarchy, right? You have this whatever, you know, and then it's aminoglycoside. This is an antibiotic molecule, which is a process or component of antibiotic biology or chemistry, right? So, you know, if antibiotic molecule, this gives you no information, right? You know, at least in this another context it would, but in this context we already care about antibiotics. So this confers resistance to an antibiotic. Yes, this was the entry point. Those were the table stakes, and then. And internally and for ArgNorm, what we decided was that the next level is probably the best one in terms of this balance. So this is, in terms of the arrow, these are the children of the antibiotic molecule term. So arrow, this one. So this is the parent term, and then subclasses exist. Yep, and then these, which I believe, if let me check, this should be 55. Oh no. Okay, no, it shouldn't be 55. It should be. Children exist. Subclass. I don't want this. Oh, maybe subclasses is everything, including the. Okay. '61. Okay, I think this. Okay. Okay. Yes. All right. So subclasses gives you all of the basically all of the subtree at that there, and we actually only want the children. And yeah, and I guess 61, maybe 55. My memory of 55 was an earlier version of arrow. So yeah. Okay, so let's do it. So these are our antibiotic classes. Okay. All right, and here you can see, and also, I think this is much nicer than. So I think a lot of, people, perhaps mainly beginners, would be tempted to write it like this. Okay. I mean, and this is fine as far as it goes, but I think this is better, because this says exactly the same thing. Maybe it's it's a little bit less easy to read if you're beginning, and this is maybe why beginners would prefer to write the English language version of this. But the big advantage is that here the Python interpreter is going to check that this is true. So comments in English have a horrible tendency to get out of date, and these are actually often so so if I did something like this, and then this. So if I did this, okay, in this case it doesn't work, but let's say something like this. Does this work? This one doesn't. Okay. None of these exist. Oh my god, this one exists. Okay, so if I did something like this where this is incorrect, then everything else would seem to work for now, and then much later the results would look completely off, and if there was a comment, and the comment would really not help. In fact, the comment would actively trick us, whereas with this, this active comment, if you want, or this comment that the Python interpreter checks, then if we somehow make a mistake, I really don't believe that the arrow group would ever do something that hostile to its users. But if for some reason they decided, oh yeah, we're going to renumber things, and antibiotic molecule is now going to be something else, and then this would immediately catch that. So in general, I think documentation is good. Code comments are a code smell. When you have comments, and what I mean is like comments for individual lines of code, generally I find that to be a sign of that's sometimes they're needed, but often there are better solutions, and I think this is a better solution to specify that information. So because this is actually checked, it cannot get out of date, and it says the same thing. And all right, so okay, where was I? Okay, so now we have these AB classes, and so now what I want to do is this. Yep. Okay. Cuts. Okay, that's all right. So now so now I just print the okay, so now we have EPT-A is a peptide antibiotic. I guess this was the colistin. So this is beta-lactam. Okay, I'm gonna just okay, I just want to check that. So here we were doing this, right? Okay, yeah. Yeah, okay, so I was just double checking this. Yeah, so in this case, so in this case, the gene we had was this one, 2972, and arrow does not record a confers resistance to the drug class for it, but it records for its parent, VAN-T, which is, then it records that it's a glycopeptide antibiotic. And so that makes some sense, but it means that we need to fix here the code. Okay, so actually let's do it a different way. Let's do all parents set. Yep. Oh, okay, this is okay, this makes more sense. Or at least we have yeah, okay, so yeah, so some of these were not present before. So okay, so so now what we're doing is, okay, for everything in the cluster, then first of all we collect all the parents, or All parents is bad. Let's all super classes. All super classes. This is a set because we're going to be seeing the same thing over and over again. And then we go over all of them. Does this work? Okay, I'm just simplifying the code a little bit here. Okay, then we go over all of the classes and all superclasses. Yep. So I don't know, there's something. Yeah, we go, oh, okay, this works. Then we go over all of the superclasses, and then we get all of the superclasses to the superclasses. Sorry, then we go over all the superclasses, then we check if they have either confers resistance to antibiotic or confers resistance to drug class. And then if they do, then we get the parent at the right level or the ancestor at the right level, which is the one that's a member of these AB classes that we care about. And then finally, we just print everything. Okay. And okay, frankly, I'm not 100% sure that we've learned much, but we have for sure really, or I have for sure learned a lot about the sorry, this was wrong. I have for sure learned a little bit more about arrow. And actually now, so in argnorm, and I'm actually going to check that right now, just switching over to drug categorization. Yeah, so argnorm, okay, I could see we could have done it this way. Import argnorm drug. Let's pick one. Let's pick what was the one we were looking at before? Just want to check that in argnorm we are doing it, how we're doing it exactly. Yeah, let's check this one. So should be a list. A list of tuples. Not sure. Oh, okay, so we should be using get immediate drug class and give it. Okay, sorry, I was using the wrong function here, so it should be get immediate drug class. Yep, and so it doesn't return anything for 3002972, which I think is a mistake. I think it should use the same logic and return. Yeah, so here. Yep, it should eventually return glycopeptide antibiotic. Yep, this is the 300081 is there. Okay, so it's another thing to look into on ArgNorm. Yeah, so again, making a lot of progress in understanding, maybe more than in anything else. All right, so let's just wrap up for now. See where we are. Yep. Okay, and we're in branch log. This is correct. Okay, and that's all we have for today. Let me just push the log. So that's all we have for today. So we've done more or less exactly 1 hour. Yeah, so sorry about this. The camera fell, and I think now I'm a little bit off centered. Yeah, so hopefully next week we will have fewer issues with the technical aspect of things. Hopefully nobody will be sick in the household, so everything will work there. In the meanwhile, I hope everybody's okay. I will check in on the mailing list and on Discord, and so have a nice day or evening, and I will see you all next week.